Here is today's question. Suppose A, B, C, D are non-negative such that A squared plus B squared equals to AC plus BD and C squared plus D squared is not zero. We are asked to find the maximum and minimum values of the following expression, which is AD plus BC minus CD over C squared plus D squared. Let J to be the expression that we want. Then we can try for small value of A, B, C, D. So suppose they are all the same, then J will equal to 1 plus 1 minus 1 over 1 square plus 1 square, which is J is equal to half. And suppose A, B, C, D is equals to 0, 0, 1 and 1, then J will equal to 0 plus 0 minus 1 over 1 plus 1, that is a negative half. From these two values, we know that the maximum of J is at least half, and the minimum of J is at most negative half. Now this gives us easy lower bound. Since A, B, C, D are non-negative, so AD plus BC must be greater than or equal to 0, which means that AD plus BC minus CD greater than or equals to negative CD. After which, divide by C squared plus D squared for both sides. We know that J is at least negative CD over C squared plus D squared. We claim that this is at least negative half. This is so because by AMGM, C squared plus D squared greater than or equals to 2CD. So half is greater than or equals to CD over C squared plus D squared. And therefore, negative CD over C squared plus D squared greater than or equals to negative half. So meaning that J is greater than or equals to negative half. And the equality holds if and only if C equals to D equals to B equals to 0. Okay, now we solve the lower bound. How to settle the upper bound? So from the condition A squared plus B squared equals to AC plus BD, we can write as A squared minus AC plus B squared minus BD equals to 0. So A minus C plus B minus D equals to 0. So now we let this A minus C equals to X, B minus D equals to Y. AX plus BY equals to 0. Now, this means that AD plus BC minus CD and also C equals to A minus X, B, D equals to B minus Y. So you have AD equals to A, B minus Y plus B, A minus X minus A minus X, B minus Y. So AB minus AY plus DA minus BX minus AB plus AY plus BX minus XY. So AB cancel with AB, AY cancel with AY, BX cancel with BX. So we left with AB minus XY. For the denominator, C squared plus D squared, A minus X squared, B minus Y squared. So it is A squared minus 2AX plus X squared and B squared minus 2BY plus Y squared. Since AX plus BY equals to 0, so this left with A squared plus B squared and X squared plus Y squared. So this means that AB minus XY over A squared plus B squared plus X squared plus Y squared. Now by AMGM inequality, A squared plus B squared is greater than or equals to 2AB. X squared plus Y squared is greater than or equals to 2XY. Now we put a modulus XY because X and Y can be positive or negative. So this means that AB less than or equals to A squared plus B squared over 2, and modulus XY less than or equals to X squared plus Y squared over 2. And also note that modulus XY is greater than or equals to negative of XY. So when we take the sum of the inequality, we have AB minus XY is less than or equals to A squared plus B squared over 2 plus X squared plus Y squared over 2. This means that AB minus XY over A squared plus B squared plus X squared plus Y squared is less than or equals to a half, which means that J is less than or equals to half. And we also see that the equality holds if A equals to B equals 1 and X equals Y equals to 0. We conclude that the maximum of J equals to half and the minimum of J is equals to a negative half. And that's all for today's problem. Hope you enjoyed it. See you again next time. Bye bye.